Kia ora koutou katoa, it's Mrs. Goodson here, and this is video 12 for Chemistry 2.4 Bonding and Structure, and it's about the properties of metals. Most metals have similar properties, and so we say they have typical physical properties of metals. They have high boiling points and melting points. They are strong and hard. They are good conductors of electricity and good conductors of heat. They have a high density and they're malleable. They can change shape without shattering, and they're ductile, which means they can be drawn out into wires without breaking. This makes metals very useful. What things can you think of that are made of metal, and why are they made of metal? Some metals have properties that are not typical. Mercury is the only metal that exists as a liquid at room temperature, which does make it a useful metal for things like making things like thermometers, but it's the only one that's a liquid. All other metals are solids at room temperature. Elements in group 1 have very low melting points but also low densities. For example, over here is a picture of sodium. It is reacting with the water, but it's also floating because it's less dense than water. So that's quite unusual to have a metal that floats. So group 1 metals have low densities. Why are metals strong and hard? Metallic bonds, as we discussed in the earlier video, are very strong, so metals are typically very strong and hard. They are difficult to break down into small pieces, and changing their shape usually takes a lot of effort. Why do metals have high melting and boiling points? The melting point is a measure of how easy it is to separate the individual particles. So when you melt something, you're going from a solid to a liquid, and then when you're boiling it, from a liquid to a gas. So the particles are moving further apart from each other. In metals, it is a measure of how strong the electron cloud holds the positive ions. It is difficult to overcome and break these metallic bonds, and you need lots of energy is needed to separate the atoms. So metals have high melting and boiling points. For example, sodium has a melting point of 89 degrees Celsius, magnesium 650 degrees Celsius, and aluminium 659 degrees Celsius. And then their boiling points are even higher. So aluminium, to boil it, you'd have to have a temperature of 2,470 degrees centigrade. So as these metals have bigger electron cloud densities, there are more electrons per donated atom, which means ions are held more strongly. Okay, so this is just a bit of a trend, but they all have high melting points and high boiling points. So why do metals conduct electricity? They also conduct heat. They are good conductors of heat and electricity because the delocalized electrons can move. All right, so to conduct electricity or to conduct heat, you need charged particles that can move and carry a current. So in metals, the charged particles are electrons, okay, delocalized electrons. Because this electron cloud is mobile, the electrons are free to move throughout its structure. When the metal is part of a circuit, electrons leaving create a positive end and electrons entering create a negative end. These new arrivals join the C already present. So you end up with a separation of charge when you're using metals in a circuit, and therefore you can a current will flow and you get a voltage. So here's an example exam question. Copper is often used to make electrical wires. Justify this statement in terms of the particles, structure, and bonding for this substance. So we start by saying that copper is composed of copper atoms held together in a 3D lattice by metallic bonding. So they were just describing the structure and the bonding, in which valence electrons are attracted to the nuclei of neighbouring atoms. So this part here is just describing metallic bonding. And then we need to talk about why metals make good conductors of electricity. So the delocalized electrons are free to move through the lattice, therefore good linking word there. They are able to conduct electricity, carry a current. So copper can conduct electricity and is used as wires. So this part here answers the question that we're asked about. So the first part we're just stating our definition of what a metal is, structure and bonding, and then we make sure that we answer the question that's being asked. So why are metals malleable and ductile? Malleable means that they can be hammered into shapes without shattering. So that is different to the ionic solids we saw. If you hit them with a force, the ions line up. But when you hit a metal with a force, because the bonding is non-directional, the layers of atoms can slide over each other without breaking the metallic bond. So you can hammer them into shapes and you can draw them into wires and they won't shatter. So this is because of the delocalized electrons. They allow the metal atoms to slide past one another without being subjected to strong repulsive forces that would cause other materials to shatter, especially like ionic substances. This allows some metals to be extremely workable. For example, gold is so malleable that it can make translucent sheets, very thin sheets of gold, and that makes it a very precious metal indeed. So if you get an exam question about this, it could go something like this. Magnesium can be hammered into sheets in different shapes without shattering. Justify this statement in terms of the particles, structure, and bonding for the substance. Just be aware another kind of question you can get is where you're comparing metals and ionic substances. Magnesium atoms are held together in a 3D lattice by metallic bonding, in which valence electrons are attracted to the nuclei of neighboring atoms. So describe the structure and bonding, the particles, structure and bonding of metals, and then answer the question about magnesium is malleable because the force of attraction between the valence electrons and the nuclei of the magnesium atoms is non-directional. This means that the layers can slide over each other without breaking the metallic bond or disrupting the lattice structure. So why are metals insoluble? So when, apart from the metals in group 1 that react with water and other lighter metals in group 2, most metals are typically insoluble. That means you can put them in water, they don't dissolve. For a substance to dissolve, there needs to be an attraction to the molecules of the solvent that is strong enough to overcome the bonding holding the solid particles together. Metals do not dissolve in water because the metallic bonds are too strong to be broken by attraction to the water molecules. An example exam question for this is magnesium metal does not dissolve in water. Justify this statement in terms of the particles, structure, and bonding for the substance. So first of all, describe the particles, structure, and bonding. Magnesium atoms are held together in a 3D lattice by metallic bonding in which valence electrons are attracted to the nuclei of neighboring atoms. Magnesium does not dissolve in water because the metallic bonds are too strong to be broken by the attraction to the water molecules. So this video has been all about the properties of metallic substances and how to explain them. So we use the structure and bonding, so the earlier video about structure and bonding, to explain the physical characteristics of metals. So that includes their ability to carry an electrical current, the ability to be shaped using a force, which we say metals are malleable, why most metals can be described as hard, why metals have high melting points, and why metals are insoluble.